Hello and welcome to the first video devlog for my introduction to design projects in Unreal Engine. So far I've only used screenshots to document my progress with this project, but I feel that the systems I build will be much easier to demonstrate in a video. I was provided with a project framework with twin stick controls and sci-fi assets. Some core functionality was also provided, such as a shield mechanic, death logic, and a functioning health bar, but there was, however, no logic provided for taking damage, so this was hard to test whether it all functioned initially. My first task was to create and decorate a room, and that's what I did here. I took this opportunity mostly to experiment with the provided meshes and produce this room as a test, and after fully familiarising myself with the project, I created a new level and named it L_startermap_iteration2. So as you can see, we were provided with all kinds of things to make this project work. We've got materials to play with, all fun stuff, and we have a student work folder. Most of the things that I do will be contained in this student work folder, but anything like modifying, let's say, the player character will have to be done on the player character, and that's what the video's for. So just to get started, we're going to go into levels, and currently the project opens up on this map that I created just as a test. I'm going to delete these out for now, and this is the level as it was when I created it, and I'd like to just have this saved separately to be able to come back and see where I started from. So what I'm going to do is I'm going to open iteration 2, and we'll save selected. So this is the level that I actually took the time to create, and we want to start Unreal Engine. Yeah, we'll get rid of this. We want to start Unreal Engine in this level each time. So I'm going to go to Edit and into Project Settings. Then we're going to go to Maps and Modes on the left side here, and we're going to change the Editor Startup Map to L_startermap_iteration2, and we're going to do the same for the game default map for now. This will probably be set to a main menu when we create one. So L_startmap_iteration2. And we'll close that, so now next time we open the editor we'll still be in this level for working on things. Now I'll just do a quick flyover of the level, but we'll play through this shortly. We've got some fans that move underneath the floor, some pipe rooms, some wires that spark, a little bit of decoration in this room. I've moved the shield pickup into here just to give it a little bit of narrative. I wanted to experiment with some verticality, so I've created, if I just hit G to hide the game stuff, so I wanted to experiment with verticality, especially for a twin stick shooter, so I decided to have this sort of bridge over an open space, just for grandeur really. It'd be nice to have some animation going on down here, something moving from one side to another. So we've got a couple of mines over here. Again, this is experimentation, I'll delete that. So we've got a couple of mines over here that when the player is nearby they'll detonate them, but we'll go into blueprints shortly. And we have the first section after the introduction where the player will be locked in a room, or at least is the intention, while we have a little bit of narrative going on, and then the player will be offered the choice to either turn back and leave and get an end state, or continue into the game and carry on playing. So jumping back up to student work now, we'll go into the blueprints, and we have a few things that I've created so far. We have the fan, The fan is really simple. So we have the mesh, and I've attached a rotating movement component onto it, and it's got a rotation rate of 180 degrees. It gives us a fan. It looks nice. In the event graph, on begin play, we're just playing a sound at location, and we're getting the world location of that static mesh, and we're just playing a fan blades sound wave turned into a cue, I believe. No, just the sound wave for fan blades, but that's what's going on there on a loop. Let's just close the rest of these because we'll open these up as we need to. So we have the mine. It's probably best to talk about the player character and the pain maker first, actually. So we'll open up the player character and discuss the damage logic. Nothing crazy. So damage logic, we're using event any damage to detect what damage has been taken, which can be called from other blueprints, and out of that damage we're basically taking that away from our health and clamping it to the max health value, setting the health variable after this, and playing some damage effects that were provided. We're then checking to see if the player's dead, and if not, nothing. If the player is dead, then we're playing death logic that again was already provided. I will be coming in and exploring all of this a little bit more when we come to edit what's here, but currently it works, so don't fix what isn't broken, I suppose. We can come in and modify it when that becomes necessary as we create more code. So that's how the damage logic is working for the player character. So to jump back to the blueprints that I've made, we're going to go to the pain maker. That's probably the most basic thing. We have a static mesh. Oh no, I'm on the wrong thing here. We have a static mesh in the viewport, and there's collision set to overlap only pawn, and on overlap we are applying damage, and we have an exposed damage value variable so that we can control how much damage that is in each instance of it that we place in a level, and that will just call over to the player character when they step onto it and deal currently 10 damage. Now that's not massively useful to us at the moment. It'd probably be okay for a panel that the player has to jump over. So to get more use out of that, we want something like, let's say, the moving laser. Now the moving laser works exactly the same. When you begin to overlap the object, which in this case it's just another cube that's been stretched out, you have a damage value as a variable, and it applies the damage to the overlapping pawn. On begin play, we set a start location from the actor's location, and then run loop logic, and the loop flip-flops to play an animation, which is just lerping a vector to another vector to make the laser move. So we have the start location plus the target location, and we're lerping from the start location to start plus target, and that sets the actor's location, and because that's driven by the alpha, that's a smooth transition. The alpha of the animation, that is, of course. So that gives us something that, if I throw it into the level, somewhere like that, just make it a bit higher up so we can see it, and we will jump back into the moving laser, and we'll change that damage value to, let's say, 40, the same as the mines, just so that we can demonstrate this killing the player character. and not have to be sat here while it passes through us constantly. As you can see, each time the laser passes over us, we take damage until we die. And that's the same for the general Painmaker. We can walk into this and just pass over it constantly until we die. Okay, so we'll delete both of those out. We can also add a rotating movement component, like to the fan, onto the Painmaker. We've made that as a separate blueprint here. You can come in, and again, this works much the same, where it will rotate round and keep on hitting the player until they're dead. We might as well let this just finish killing us. There we are. Yikes, once again. So again, we'll delete that because we don't need that there. This is just for testing purposes. As for the mines, that's a touch more complex, the way that that works, but it's still nothing too crazy. So if I go into the viewport here, so that I can select the different things you can see, we have an inner sphere and an outer sphere collision for a static mesh. The outer sphere runs one piece of logic, which is to detect the player and change the colour and play sound effect to make it seem like the mine is activated. The inner sphere is the detonation sphere, and when the player crosses over the inner sphere, it activates the bomb and starts the timer until detonation. To see that in the event graph, we've got the outer sphere detection up here. So we're setting a variable to see if the player's in radius on overlap. We're checking to see if the mine is live, if it's already been triggered and is waiting to explode. If it's not live, then we're going to set the material on the mine, and we're going to play a sound to let the player know that the mine's activated. On end overlap, if the player's not in the radius, we're setting player to not be in the radius. We are checking again to see if the mine is live, and if it's not live, then we're setting the material back to the green that we had. For the inner sphere, we are setting the mine to be live, so that prevents these from calling beyond this point. We're setting the material, so that will be the red emissive light at the top. We're setting visibility on a radius display, which if I go back to the viewport, we have that here, and if I just search visible, so we have this just to work as an identifier to show the range of the bomb's explosion. Just a nice little visual indicator for the player there. We'll set that to not visible again. Okay, back over to the event graph. So we're setting that to be visible here, and we're starting the fuse timer. The fuse timer plays a sound at location for the beeps, like the bidip 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 before it explodes. Then we're setting a detonation count. We're using a detonation count variable as an integer, plussing 1 to it and setting the count. We've got a fuse tick for the delay, for how long we want between each tick of the bomb. And here we can say however many times we want it to count up. In this instance, I've got it set to 3, so 3 times 0.8 seconds before the mine explodes. And if the value hasn't reached 3, so false, it runs fuse timer to do this process again. But if it has reached 3, then it will detonate, which is this event down here. So detonate checks to see if the player is in radius, so we know whether to damage them or not. If they are, then we apply damage and play sound at location. If they're not, then we just play the sound at location. From that we're spawning a Niagara system, just a Niagara explosion that I've created. At location, so at the actor's location, and then we're destroying the actor so that it's no longer in the scene. Okay, so moving on from that, we have logic for doors. Now this is nothing too crazy, it's a double door, and we're setting the location of each door as a start location, and we have variables set up for the target locations for each of those doors. Then we have a trigger box, so just a box collision here, that when the player overlaps it, come back to here where we are, so when the player overlaps it, it goes into a sequence to run both of these animations, and the animation basically takes the start location of the door into alert vector, and then into the B pin we've got the start location and the target location together, so they're just combined to lerp along to the new value, and we set the world location. And again, because this is driven by the alpha of the animation in both instances down here, it's a smooth transition, nothing too crazy. And then for the end overlap, it basically runs the animations from reverse. As you end the overlap, I've got a small timer here, so this is set to ½ second as a hold open timer, so that the door doesn't just instantly close as the player moves away from it. It has that short delay before closing. So we'll minimise again. So the next thing that we have, it's going to be quick and easy talk about the sparking wires. So this is again nothing too crazy. I've got the static mesh, and I've got 2 arrow components, and in the event graph all we're doing is on begin play run spark, and spark takes a random floating range between 0 and 3 to use as a delay, and then it plays the sound at location of the static mesh. It spawns a Niagara system for sparks at the location of the arrow, and then it does the same for the other arrow. So random floating range to use as a delay, a smaller timer this time because it's the second one we want it to follow up. We're getting the world location of the static mesh, and we're using that to play sound at location. Then arrow 2 for the world location, spawn the particle system, and then run spark again, so it just continuously loops through that logic. I have 2 of those. The other one is set up exactly the same, just using the second model mesh that was provided for wires. As you saw, well, probably heard play earlier, we have the suspense trigger, which is literally just a box collision, and when the player passes through it, it plays a sound 2D once. I've created a standing lamp as a blueprint. There's no logic inside this currently. It is purely a lamp with a point light attached, and the static mesh, the shadows are turned off just already for me, so I don't have to keep messing around with that, and that's just for my ease of life, just to save me time messing around adding lights to things. Outside of that, most of this is experimental now. I've created a sound manager, and this sort of works in tandem with the beat piston, so I'll open that as well so that we can start working through that. Now the sound manager creates a sound 2D at so 2D, so it just plays through both speakers using a soundtrack that I've created. And then it sets that as a variable. Then we're using that variable to set the volume to 0 so that we can call it when we want to call it. And then I'm using a mechanic that I've recently discovered, creating Quartz Clocks and using quantized clocks. Now what this allows me to do is to take the BPM of my track and calculate the beats of the track and use that to call functions in Logic. So I have a quartz quantization boundary here that we can use to detect beats, bars, halves, wholes, like that. There's a lot we can do with this, and it's still very much experimentation for me at the moment. But using that, we can affect code inside other blueprints. So here, there we are. So we're getting a handle for a clock, a quartz clock, and we're using the clock name derelict beat that we set in the sound manager. And then we subscribe to a quantization event, which is this here, the quantization boundary. And wherever we set that to, so it's going to be beat or what are the other options? It's going to be beats or bars, or wherever we decide to set that to. It's going to call this logic each time. So I've currently got this on a flip-flop just to move a platform up and down. And to see that working, if I can throw the beat piston just into the level here and move it up. There you go. So as you can see, the platform's moving with the music. Now, I currently have the BPM set to 80, and I feel like that's ever so slightly off for the track that I created, and I need to check that out in Fruity Loops just to get the exact values there. But once I've got my head around how this works, I feel like I can make my environment feel much more alive. A couple of other things that are worth pulling open. So I have created various materials. None of these are particularly high concept things. It's things like so the M_laser, it's literally just multiplying a colour and feeding it into emissive colour. I have the mine radius material. This is an instance, and this comes out of the hologram material. Now I followed a tutorial to produce this, and it doesn't work in the same way that the tutorial does, and that is mostly because of this texture sample here. Really, I need lined noise rather than just a general noise texture, but I threw it together just to see how it worked as a quick implementation to give myself something to use as a marker for the player for the blast radius of the mine. So it's nothing too important, and we can revisit this later to refine this and make it look nicer. And I feel like that might be it. Just having a quick look through here now. The meshes, this is just for a task for experimentation, just learning a few more processes. But I took a copy of the lamp and created a material for the lamp, so if I just throw this in here and go up close to it so we can see, just to make it look like it's been turned off, and that is for situations like this. If I just come over this end, so where we've got one lamp standing and one lamp on the floor, it just adds a little bit of depth to the scene. Makes the player ask those questions like, what happened here? Ultimately, I'm going to be turning this blueprint into something that the player can collide with, give it a small health value, and have it that when it takes damage, which will be on collision, it breaks the light, so just switches the material from this to this. Maybe, well, not maybe, it'll destroy the light as well, so it won't be emitting light anymore. All those good things. Again, nothing too crazy, but it adds that little bit of game feel. Okay, so after reviewing the footage from the first devlog, I realised that while I was running the playtests, the music was too loud to hear me talking over it. So I've just unhooked the event that calls the music off begin play and plugged that straight into ambience, which is the custom event here that just plays a sound 2D for the ambience of the level. Just compile, you'll see that the music's gone, and I've set up a few obstacles here just to actually showcase what these blueprints do. So we have the pain maker, that when we overlap with it we take damage. We'll just show that that can actually kill the player. Okay, so auto restart. We have the moving pain maker, which is the same thing, it's just been given an animation and it's told to loop between two vectors. We have the exact same thing again, it's a pain maker, it's just being given a rotating component so that it's a different style of obstacle. When you collide with this, as before, you just take the damage, and if you take up to the 100 value you die. Auto restart. Oh no, we have the suspense trigger here. So that's just a box collision with play sound 2D, and the sound is one that I created in FL Studio. These crates we're actually able to knock off. I've enabled collision and physics for these so that we can just bump these over the edge, because that's always nice to do when there's verticality in levels. And then finally we have the mines. So the mines operate with two sphere collisions. When we enter the outermost sphere collision, it activates the mine, and that's indicated by a different colour and the small sound effect you hear, the little beep. When we get closer to the mine, it activates the detonation sequence. If the player's inside that radius that's shown, we take the damage. If we're not inside that radius, we don't take the damage. After crossing over the second zone, the innermost circle, a small timer's started. It's currently 3 loops of 0.8 seconds, and at the end of that it calls detonate, which plays the Niagara particle system, the sound effect, and applies damage to the player if they're overlapping the outermost zone, which is indicated by the red laser. So now I'm just restarting so that we can show that the 3 mines together is enough to kill the player, and they're able to indeed kill the player. last thing to mention here is the doors, which I know for the entire thing so far we've been running through it, it's easy to forget them. So the door has a trigger box or collision box, box collision, over the space in front of it and behind it. When the player enters this space, the doors lerp to a vector outwards, and when we stop colliding with that collision, it waits for half a second and then closes. The overlapping model here where the door was flipping through. And with that, I believe we're finished. Thank you very much for watching, and I'll catch you in the next devlog.